Good evening, students, and today we are having paper discussion on aromatic hydrocarbons. Correct. So the discussion paper has been already sent in those respective WhatsApp groups. You just open those things. We'll go one by one. Correct. So the first question of the discussion paper was based on the formula. So the general formula for arene or general formula of aromatic hydrocarbons is option number A CnH2n, option B in fact CnH2n minus 6, option C it is CnH2n minus 4, and option D it is CnH2n plus 2. So that was the first question that we are having today. Right now, for the first one, the general formula of arene is Cn. It is the general formula is what? CnH2n minus 6. CnH2n minus 6 is the general formula of what? Aromatic hydrocarbons. Correct? So that is nothing but arenes. They mentioned it as what? Arenes. Arenes is nothing but aromatic hydrocarbons. Correct? So hence the option number B is the correct answer. Option B is the correct answer for what? The first one. The general formula of arene is CnH2n minus 6. Correct? So generally they will even mention M over here. That is nothing but CnH2n minus 6 M. M indicates about the number of rings. Right? So generally it is enough. This is the formula of what? Aromatic hydrocarbons are simply arenes. Clear? So let us go for the second one. The second question. Correct? Benzene reacts with fuming sulfuric acid to give. Benzene reacts with what? Fuming sulfuric acid to give what? So option number A is sodium benzene sulfonate. Option B is benzene sulfonic acid. Option C is sodium benzoate. And option D is all the above. Correct. If you are going through the question, they ask benzene reacts with fuming sulfuric acid. That is nothing but what? Sulfonation. Sulfonation of benzene. Sulfonation of benzene takes place, and we know that at the end we are going to get benzene sulfonic acid. Correct. So option number again for second one also it is B. It is sulfonic acid. Which sulfonic acid? Benzene sulfonic acid. I'm going to get what? Benzene sulfonic acid. Here I have forgotten to write benzene. It is benzene sulfonic acid. It is the question is based on what? Sulfonation of what? Benzene. Benzene undergo sulfonation in presence of fuming sulfuric acid to give you what? Benzene sulfonic acid. Benzene SO3H. Benzene sulfonic acid. Correct. So that is my option number B for what? Question number 2. Correct. So let us go for the next one. That is nothing but my third question. The third one. Third one, which of the following reaction is shown by benzene? Which of the reaction is shown by what? Benzene. That is my third question. So if you are going through the options, first one is addition reaction. Second one is electrophilic substitution reaction. C, third one is pi complex formation. And option D, all the above. Option D, what? All the above. So which of the following reaction is shown by benzene? See, benzene will show you what? Addition reaction. Correct. It also shows you what? Electrophilic substitution too, and it also shows you what? Pi complex formation. Hence, the answer is what? Option number D. All of the above. These all reactions are shown by benzene. Correct. So addition, electrophilic substitution, pi complex formation. So for third one, it is option D. All of the above. All of the above. Clear? All the above, all of the above. So that is my third one, option D. Correct. Let us go for the next one. That is nothing but my fourth one. Question number 4. Question number 4. Among the following groups, the group that deactivates the benzene ring. The group that deactivates the benzene ring for further electrophilic substitution reactions. Correct. So what do you mean by deactivating groups? So these are substituent groups which are attached to what? Benzene. Okay. So there are two types of groups. One is electron donating group, or else another one is what? Electron withdrawing group. So There is a difference between these two. One is electron donating, another one is electron withdrawing. We know that aromatic hydrocarbons generally undergo electrophilic substitution reactions. Correct now? They will generally undergo what? Electrophilic substitution reaction. So these electrophiles will go and attack these benzene rings, which is mono-substituted already. Correct? So now this electrophile has to come and attack this benzene. Correct? This electrophile needs electron. So this electron donating group will increase electron density at benzene. This electron withdrawing group will decrease electron density at benzene. Correct? Or nothing but you can say electron donating group will increase electron density particularly at ortho and para position. If you are drawing the resonance hybrid of this structure, you can see in resonance hybrid I get partial negative charge over here, partial negative charge over here, and partial negative charge over here. Correct? No? So this is the resonance hybrid of this structure. This suggests that electron donating group will increase the electron density at ortho and para. At the same time, electron withdrawing group, if I am supposed to draw what the resonance hybrid, I know that here I get partial positive charge. On ortho and on para positions, I am going to get what? Partial positive charge. It means electron withdrawing group will decrease electron density at ortho and para. So now electrophile is to be added. So this guy will help electrophile because electrophile is in need of electron. So there are electron rich centers, but in this case, there are electron poor center. So that is why electron donating group will increase electron density and helps electrophile to come and attack. That is nothing but electron donating group will activate the ring. It activates the ring. It activates the ring towards electrophilic substitution reaction. But this guy, electron withdrawing group, will deactivate. It deactivates the ring towards electrophilic substitution reaction. So one thing I got to know that electron donating groups are called as ring activators. Electron withdrawing groups are called as what? Ring deactivators towards electrophilic substitution reactions. So the question is based on this one. They're asking among the following groups, the group that deactivates. Right? So option number A is hydroxyl. That is nothing but my OH group. OH is a ring activator. Then option B is methyl. Methyl is an electron donor, so electron donating groups are ring activators. Similarly, option C is chloro. Option C is what? Chloro. And option D is amino. Option D is what? Amino. Option B was methyl, CH3. Option 1 is hydroxyl OH. Among these, which deactivates? The group which deactivates is what? Chloro. But it shows you positive resonance, but it deactivates the ring, chlorine. So that is why option number C. Option number C is why correct answer for what? Fourth one. Option number C is the correct. So hope you got to know what we mean by ring activators and ring deactivators. Correct. So for the question number fourth one, the option number C is correct option. The chloro group. C is the correct option. Correct now? So let's go for the next one, fifth one. The addition of chlorine to benzene. The addition of chlorine to benzene form BHC happens when they're asking the condition. See, understand the addition of chlorine to benzene to form BHC. What do you mean by BHC? Benzene hexachloride. BHC happens when I will write the reaction. Addition of chlorine to what? Benzene. I'm having benzene. I'm adding what? Chlorine. Cl2 I will add. LFCl2. I'm going to get BHC. B6 H6 Cl6. B6 H6 Cl6. That is nothing but my benzene hexachloride. BHC. Benzene hexachloride. Or else you can say what? BHC. So this reaction will take place in presence of what they are asking. In presence of what? Say the conditions they have given. We just go through those things. The conditions is one, chlorine is bubbled through benzene. Option B, when the mixture is kept in dark. Option C, when the mixture is exposed to sunlight. Yes, that is correct, because this reaction will take place in presence of what? Sunlight. So sunlight, in presence of sunlight, this is going to form a BHC. correct addition reaction. So this is the correct suitable condition for the formation of BHC by using what benzene. So option number C for fifth question, the correct answer for fifth one, it is again what option C. Option C is the correct number. Clear? So let's go for the next one, sixth one. The next one is what? Sixth one. So go to the question. Go through the sixth question. Sixth one. Reaction of NO2 plus is easier in reaction of NO2 plus. Reaction of what? NO plus. NO plus is nothing but my electrophile. Correct? So they have taken as an example NO2. So attack of NO2 or reaction of this NO2 is easier for whom? Among one is benzene, A is benzene, B is toluene, C is nitrobenzene, D all the above. So option number one, it is benzene. Yes, it will undergo electrophilic substitution reaction. Next, option B is toluene, and the third one is nitrobenzene. The third one is what? Nitrobenzene. Ring deactivated it is. It won't help electrophile to come and attack. So either this one or this one. Then among these two, addition of methyl group will further increase the ease of what attack of what electrophile to come and attack. So among these three, option D is all the above. So among these three, one is more reactive towards what? NO2. Or else you can say the reaction of NO2 is easier in case of what? Toluene. Because toluene is a CS3, there is presence of CS3, CS3 donates, it acts as a ring activator, it increases electron density at an ortho and para, so it is easier for NO2 plus to come and attack. So that is why for sixth one, option B is the correct answer. Toluene, T-O-L-U-E-N-E. Correct. For sixth one, it is option number B. Option B is the correct. So toluene will generally undergo electrophilic substitution faster compared to benzene. Benzene undergo faster compared to nitrobenzene. So my option is second one B, that is nothing but my toluene. So this was my sixth question. Correct. So let us go for the seventh one. Let us go for the seventh one. What is seventh one? Benzene is obtained when phenol is distilled with. Benzene is obtained. So I got to know the product side I am having benzene. It is clear from the question. Benzene is obtained when phenol is distilled with. So one of the reactant also they have given. Phenol. Phenol has to undergo distillation so as to give you a benzene. In presence of what they are asking? In presence of what? So that is nothing but benzene is obtained when phenol is distilled with what? So that is my question number 7. So what might be the answer? Let's go. First one is copper turnings. Option B is aluminum dust. Option C is zinc dust. Obviously, option C is the correct answer. You can go through the preparation of aromatic hydrocarbons. In that, even in NCERT itself, they have clearly mentioned that whenever phenol is heated or distilled, in presence of what? Zinc dust. In presence of what? Zinc dust, you are going to get benzene plus zinc oxide. Benzene plus what? Zinc oxide. So here the question mark, I have removed question mark and I have written what? Zinc dust. So zinc dust is best to prepare what? Benzene by using what? Phenol. If you are distilling with zinc dust, phenol gets converted into what? Benzene. So option number C. For 7th, it is option number C. Correct? So here we have completed this 7 questions of discussion paper. Let us go for the 8th one. I'll drop this before, and till that you read 8th one, you go through the 8th one, try to solve it. Let us go for the 8th one. So 8th one is, I'll write over here, 8th. Heating a mixture of sodium benzoate and soda lime gives sodium benzoate. And it means sodium benzoate is nothing but a salt of sodium salt of benzoic acid. Sodium salt of what? Benzoic acid. Sodium benzoate. Okay, sodium salt of benzoic acid. So this sodium salt of benzoic acid, when it is treated with soda lime, they said soda lime. What do you mean by soda lime? Soda lime is mixture of what? Calcium oxide plus NaOH. It is mixture of what? Calcium oxide plus NaOH, soda lime. It acts as decarboxylating agent. It acts as a decarboxylating. It acts as a decarboxylating agent. It removes carboxylic group. Then obviously, when this guy is made to react with what? Calcium oxide and NaOH. Soda lime. Mixture of this one is called as what? Soda lime. So Na2CO3 will go out. Na2CO3 will go out. And what you will be left with? You will be left with what? Benzene. At last, I will be left with what? Benzene. Correct? So this is what happens when you are heating mixture of sodium benzoate with what? Soda lime. When sodium benzoate is heated with soda lime, we are going to get benzene. Hence, my option, correct option for 8th one is what? It is D. For 8th one, it is D. Clear? Very good. Let us go for the 9th one. 9th one. So there is a correction in the key answer that we have already posted in the WhatsApp group. For 9th one, we have mentioned that it is option D. For 9th one, I'm talking about the 9th one. 9th one, we have already mentioned the key answer, it is D. It's not D. Let's go and see. Benzene can be obtained by, they said. They said benzene can be obtained by. They have given 3 reactions over there. And at the last, they said all of these are used to prepare benzene. But let us go through. First one, A, it is phenol plus soda lime. NaOH, calcium oxide, they said. NaOH, calcium oxide, just now we have discussed. Decarboxylating agent. Decarboxylating agent, for decarboxylating agent, we need a salt of acid, like sodium benzoate earlier. But here we are having phenol, they said. In option A, they said what? Phenol. So by using that one, we can't prepare benzene. So it cannot be option A. Right? At the same time, if option A is wrong, obviously D can't be the answer. All of these. D is all of this. It cannot be. So A is not an option. D is also not an option. Let us go for the second one. They said phenol plus zinc and heat. Just now we were discussing when phenol is heated with what? Zinc dust. Earlier we have discussed. We are going to get what? Benzene plus zinc oxide. Correct? Benzene plus zinc oxide. So we can prepare by this reaction. So option B, by using option B, we can prepare what? Benzene. That's what they said. Benzene can be prepared by. See, you can go through C option too. C6H5N2Cl. That is nothing but my benzene diazonium chloride. Benzene diazonium chloride on reaction with water, on warming with water, will give you what? Phenol, but not benzene. They are asking benzene. So it cannot be option A, it cannot be option C, it cannot be option D. So it has to be what? B. Phenol on treatment with what? Zinc dust. So for 9th one, it has to be B, not D. Correct? So let's go for the next one then. Which is next one? Yes, it is my question number 10. Acetylene on polymerization gives acetylene. Acetylene in the sense what? Acetylene is nothing but my CH triple bond CH. So this guy will undergo polymerization at very high temperature and high pressure. It's a monomer. It's polymer. It will undergo, you can say, cyclic polymerization. So alkyne or acetylene will undergo cyclic polymerization so as to give you what? So as to give you acetylene will give you what? Benzene. Obviously, that is the way of preparation of what? Benzene. Cyclic polymerization, you can say. So it has to be my option number B. So for 10th one, the correct answer is what? B. Correct? So acetylene on polymerization at very high temperature and pressure when drastic condition is maintained. So this will undergo polymerization and will give you what? Benzene. Correct? Cyclic polymerization, you can say. Correct? So option number B it is. So let us go for the next question. That is nothing but my 11th. The products A and B in the reaction sequence. The products A and B in the reaction sequence. So let's see the reaction sequence. For 11th, they have given C6H6. That is nothing but my benzene. Correct now? Benzene. This benzene is treated with both concentrated HNO3. Correct now? Concentrated HNO3 and concentrated H2SO4. Concentrated H2SO4. These two are nothing but my nitrating mixtures. These two are called as what? Nitrating mixtures. So they produce NO2 plus as a what? As a what? Electrophile. So that NO2 plus, the electrophile will come and attack what? Benzene. So benzene is going to become what? Nitrobenzene. It is going to become what? Nitrobenzene. So this is my A. According to the reaction sequence. Then this A is treated with stannous plus HCl. Stannous in HCl. That is nothing but my reducing agent. So this nitrobenzene is undergoing what? Reduction in presence of stannous in HCl. So when this happens, reduction in O2 becomes NH2. NO2 becomes what? NH2. Nitrobenzene is reduced to what? Aniline. That is nothing but my B. It is called as what? Aniline. B is aniline. A is nitrobenzene. These are my A and B. Now we go through the options for question number 11. In first option, it is nitrobenzene. Okay, correct. But B, they said phenyl hydroxylamine. No, it is not. Let's go for option B. A is nitrobenzene, correct. B is aniline. So that is the correct option. No need to go for third C option. So for 11th one, the correct option is what? B. Please remember, benzene is undergoing nitration. So A is my nitrobenzene. This nitrobenzene undergo reduction in presence of stannous and HCl. NO2 gets converted to what? NH2. So nitrobenzene is reduced to what? Aniline. A is nitrobenzene, B is aniline. That is why it is option number B. So 11th one, it is option B. Okay, let's go for the next question. Let us go for the next question. 12th one. What is 12th one? What they have asked you, see. 12th. The reaction of benzene with SO3 dissolved in H2SO4. SO3 dissolved in H2SO4. That is nothing but H2S2O7. H2O7 is nothing but oleum. Correct? So that is nothing but sulfonation. Correct? Sulfonation. So let's see. The reaction of benzene with SO3 dissolved in H2SO4 gives as an intermediate. Gives as an intermediate among these water. Yes, during the sulfonation, you can go through the mechanism of sulfonation, or you can go through the mechanism of electrophilic substitution reaction of aromatic compounds. The intermediate formed is nothing but my option number B. That is nothing but my option number B. Correct? So during the mechanism, if suppose there is H and there is SO3 minus, there is H and SO3 minus, here up to here there will be what? Resonance. Half resonance. Resonance is not completed over here. Correct? So this forms as what? Intermediate in case of what? Sulfonation. That's what they said. The reaction of benzene with SO3 dissolved in H2SO4 gives as an intermediate. That is nothing but my option number B. Correct? So you just go through what the mechanism of electrophilic substitution reaction of aromatic hydrocarbons you will get to know. Correct? In that they have clearly mentioned instead of SO3 minus they have taken E electrophile, which electrophile will come and attack. Correct? So 12 it is option number B. Correct? Let us go for the next one, that is nothing but my 13. So the next question is what? 13. In chlorination of benzene, the reactive species is the chlorination of benzene. The reactive species is when you are asked to go for chlorination for benzene, you are supposed to add what? Chlorine. Right? Chlorination. See, benzene, I am taking benzene. This benzene is undergoing what? Chlorination in presence of what? Iron or FeCl3. Dark in absence of sunlight, in fact. So what I am going to get? I am going to get chlorobenzene. Correct? This is the reaction. What they are asking is, in chlorination of benzene, the reactive species. So I will add a halogen carrier, FeCl3. You can take FeCl3. It acts as halogen carrier. It withdraws one of the chlorine. Then I'll be left with what? FeCl3 will become FeCl4 minus. Correct? Then I'll be left with one of the chlorine. That is nothing but my electrophile, Cl plus. This electrophile will come and attack any of the carbon among these six so as to give you chlorobenzene. So, in case of chlorination of benzene, the reactive species is nothing but my electrophile. Which electrophile? Cl plus, chlorine electrophile. So, option number A is correct for what? Question number 13. Correct? So, for question number 13, option A is the correct answer, you can say. Okay? So, chlorination of benzene. Similarly, let us go for the next question. That is nothing but my 14th one. So the questions are very simple. If you already gone to NCERT or the online classes of the chapter, it will be easier for you people to solve. Let us go for the next question. That is nothing but my 14th one. Which can be used in Friedel-Crafts acylation? Which can be used in Friedel-Crafts acylation? What do you mean by acylation? It is addition of acyl group. It is addition of acyl group. So let's say I'm having benzene. I need to go for acylation. Means I'm supposed to add what? Acyl group. Acyl group in the sense it is nothing but my CO, CH3. This group. Correct? So acylation is nothing but acetylation. Acetyl group is to be added. So acetyl group is to be added so as to get what? Acetophenone. That is nothing but my COCS. This is acylation. Friedel-Crafts acylation, you can say. So question is based on this one. So I want acyl group over here for benzene. So it is acylation. What's they are saying? See, which can be used in Friedel-Crafts acylation. In Friedel-Crafts acylation, I even know that here I am going to take AlCl3 and hydrous AlCl3. What would be my another reactant? What would be my another reactant? Correct? See, what would be my another reactant? Taking alkyl acylation of benzene as an example in Friedel-Crafts, what I can add? Option number A is acetic anhydride. Option number A is what? Acetic anhydride. CH3 COO. See, CH3 COO CO CH3. This is my option number A. Option number B is CH3 COCl. CH3 COCl. Option C is CH3 CH2 COCl, CH3 CH2 COCl. Option D, they said all. They said all. Which is possible. I want to introduce this group to benzene. Whether I can use this or this or this or I can use all. Acylation. Acyl. See, it doesn't mean that there should be only what this acetyl group. Acylation. Acyl group can be what? CH2, CH3 2. This also can be added. Acylation, Friedel-Crafts acylation. It doesn't mean that I'm supposed to take only one carbon over here. You can even think about two. So acylation or acylation can also be done by using what? This acetic anhydride group. Acetic anhydride also gives you what? Acetyl chloride. This acetyl chloride also gives you what? Not acetyl chloride, in fact acetophenone. Acetyl chloride also will give you acetophenone. So this guy also gives you what? Acetyl chloride or acylation reaction. Not only acetophenone, in fact you can even get what? CH2 CH3 2. Correct? So this is addition of acyl group, acylation. That is why all these three reagents can be used for what? Acylation. Hence, it is my option number D. Okay. So for which? For 14, which can be used in Friedel-Crafts acylation. It can be acetic anhydride, it can be CH3COCl, it can be CH3CH2COCl. Correct? So this guy acts as electrophile. This electrophile will come in attack and forms a bond. So for 14th, it is my option number D. Okay, 14th, it is my option number D. So let's go for 15th one. Let's go for 15th. Acylation. after acylation, after this question, we are supposed to talk about the next one, that is nothing but my 15th one. So let's discuss 15th. Again, 15th is also based on Friedel-Crafts reaction. Anhydrous AlCl3. Just now I have written. Anhydrous AlCl3 is used in the Friedel-Crafts reaction because, right? Anhydrous AlCl3 is used. For example, I'll take alkylation. I'm talking about alkylation. Let us imagine I'm talking about what? Alkylation. CS3Cl. Alkyl is introduced over here in benzene. So this reaction will take place in presence of what? Anhydrous AlCl3. Anhydrous AlCl3 acts as a Lewis acid. In this case, it acts as what? Lewis acid. It is in need of electron. That is why it will try to coordinate with the electrons present on chlorine, and it carries halogen. So AlCl3 will become AlCl4 minus and forms a positive charge on this carbon. So this CS3 will act as electrophile and will go and attack benzene and will give you toluene. So that is Friedel-Crafts. They are asking what is the role of anhydrous AlCl3. Correct? That's what the question is. What anhydrous AlCl3 is used in the Friedel-Crafts reaction because it is. See, I want CS3 should be free. This chlorine has to go out. I need a halogen carrier. That halogen carrier is Lewis acid. Lewis acid is nothing but electron acceptor. Who can accept electron? The one who is electron deficient. It is AlCl3. Its octet is not completed. So it will become AlCl4 minus by accepting. Earlier it was electron deficient. So that is why anhydrous AlCl3 is used over here in Friedel-Crafts reactions, whether it may be alkylation or acylation. It will try to coordinate with the lone pair of electrons present on halogen. It is in need of electron because it is a Lewis acid. It accepts electron. So why it is used then go through the options over there. It's electron rich. Option B, it is soluble in ether. Option C, ionizable to chloride and aluminum ions. Option D, electron deficient. That is nothing but Lewis acid. Lewis acid is the one who accepts. The one who accepts is electron deficient. So option number D is correct for my question number 15. Clear? So for 15, it is my option number D. Clear? So let's go for the next question. So I have written 15 questions over here totally. So I'll rub all this so that it will be easier for me to explain and write the reactions or the reasons for what remaining questions. Okay. So till now we have solved those 15 questions. Clear? So next one is 16th one. You just go through the question 16th one. Solve it for you people. So let's talk about question number 16. 16. Nitration of toluene takes place at nitration of toluene. I'm having toluene CS3. Nitration means in presence. Nitration is nothing but nitrating mixture. Any nitrating mixture. Nitrating mixtures are nothing but HNO3 and H2SO. Both are concentrated. They will produce NO2 plus. NO2 plus. Or else we can say electrophile or let it be NO2 plus. NO2 plus. It has to go and attack toluene. Where it will attack? CS3 is electron donor. This electron donating group will increase electron density at ortho and para. Meta position will be unaffected. Clear? So CS3 will increase electron density at ortho and para. This incoming molecule, which is an electrophile, is in need of electron. So obviously this guy will come and attack either ortho or what? Para position. It will come and attack ortho and para position. So I am going to get two products. So toluene ion nitration gives you what? Ortho-nitrotoluene. This is ortho-nitrotoluene. and my another product is para-nitrotoluene. My another product is what? Para-nitrotoluene. P-nitrotoluene. Or you can say para-nitrotoluene. Right? It's not visible. This is nothing but my para-nitrotoluene. So I'm going to get two products, obviously, because this electron donating group will increase electron density at ortho and para. So this incoming molecule needs an electron. So it will obviously go and attack ortho and para. Clear? So if it was an electron withdrawing group, then electron density will be less at ortho and para. One thing you remember, meta will be unaffected. So ortho and para, electron rich now. If it is an electron withdrawing group, ortho and para will be electron poor. That is why it is meta directing. But CS3 in toluene, CS3 is ortho and para directing. So you are going to get two products. One is ortho and one is para. So let's go through the question. Nitration of toluene takes place at both ortho and para position. So for 16, it is my option D. Clear? Option D is the correct answer. So let's go for the 17th one. Which of the following reaction is not an example of substitution reaction? Which of the following is not an example for substitution reaction? So let's go through the question number 17 in option A. It is benzene undergoing nitration so as to give you nitrobenzene. It's an example for electrophilic substitution reaction. Okay. Let's go for B. Benzene is undergoing alkylation in presence of AlCl3 so as to give you a toluene and HCl. Means it is Friedel-Crafts alkylation. Friedel-Crafts alkylation and Friedel-Crafts acylation are examples for what? Electrophilic substitution reactions. Clear? So one is also electrophilic substitution, second one is also electrophilic. They are asking which is not an example. Let us go for the C. Benzene plus chlorine in presence of sunlight. UV light is nothing but sunlight. So as to give you what? PHC. So that is an example for addition reaction, not electrophilic substitution. So for 17, the correct option is what? C. Correct? See, it is not an example for what? Electrophilic substitution reaction. Let's go for the 18th one. Among the following compounds, 1, 2, 3, 4, they have given the order of decreasing reactivity towards electrophilic substitution reactions. So let's go through the compounds that they have given, or the molecules that they have given. Correct? So let's go through one by one. First one is toluene. First one is what? Toluene. Methyl benzene. Correct now? Second compound is benzene. Second compound is benzene. And the third one is anisole or methoxybenzene, you can say. OCH3, methoxybenzene. And the fourth one is CF3 benzene. CF3 and benzene. Right? Trifluorophenylmethane. Trifluorophenylmethane. So we are supposed to talk about who is more reactive among these towards electrophilic substitution. If an electrophile is coming and attacking, to whom it will come and attack first, then next, then next. So I am supposed to arrange these things in the increasing order of their reactivity. See, this is toluene, this is benzene, this is anisole, and this is my trifluorophenylmethane. Correct? This is 1, 2, 3, and 4. So let's go. It is benzene, it is CF3. There are electron withdrawing groups. I need electron donating group so that it will be easier for electrophile to come and attack. So if you are going through these four compounds, I know that in toluene there is CS3, in anisole there is OCS3. These two are electron donating groups. So among these four, both these are more reactive towards electrophilic substitution reaction. Then among these, comes first? Obviously the one who is strong donor. Then who is strong donor over here? Third one, anisole. So third one is more reactive towards what? Electrophilic. And obviously it has to be my first. 3, 1. Then I am having benzene and followed by this guy, trifluorophenylmethane. Among these two, obviously there are electron withdrawing groups. These are electron withdrawing groups. They deactivate string. but benzene is somewhat more reactive towards electrophilic substitution reaction compared to this one. So that is why this second has to come first, and my least reactive compound is what? Fourth. My least reactive compound is what? Fourth. So that is why, which option is correct? I have arranged these things in the what? Decreasing order. Decreasing. This is more reactive, this is least reactive. Decreasing order of reactivity towards electrophilic substitution reaction. Electron donors will help for electrophile to come and attack. Electron withdrawing groups will not. Okay? So electron donating groups substituted. If these are present on benzene, then those are more reactive than benzene. Clear? That is this order. So for question number 18, option number B is correct. Option number B is correct. So clear of this. Let us go for the next question. That is nothing but my 19th one. Let's go for 19th question. 19. In Friedel-Crafts acylation, please remember, in Friedel-Crafts acylation reaction, the electrophile is acylation means earlier we were talking like I have written CS3 CO alkylation. I mean acylation. Acetylation means this one. Acylation generally means here I'll be having acylation. So here I say that there should be a positive charge. That is nothing but this compound. This is an electrophile in case of what? Acylation. Correct? So this PC is reactive towards what? Acylation. In Friedel-Crafts they have mentioned. Obviously, this is my answer, and that is nothing but my option number B. So for question number 19, option B is the correct answer. Correct? Let's move for the 20th. Again, the 20th is based on what? Friedel-Crafts alkylation. Benzene is made to react with methyl chloride. Correct? No? Alkyl chloride in presence of AlCl3. Obviously, you are supposed to get what? Toluene. That is direct. So 20th is my option number B. Okay. So let's go for 21 then. 21. So 21. The chlorination of toluene in presence of ferric chloride. Earlier I have written chlorination of toluene, but this time it is what? Toluene. So that's what earlier I have written. Toluene is undergoing chlorination. Let's see in presence of what? Chlorination in presence of ferric chloride, FeCl3, which acts as Lewis acid or halogen carrier. Gives what? Obviously, this FeCl3 will abstract one of the chlorine and will go out as FeCl4 minus. One of the chlorine will be left with positive charge. That chlorine acts as an electrophile. It has to go and attack toluene. Where it will attack? Obviously, it is going to attack an ortho and para. Simple. So that is right. It is my option number D, ortho and para chlorotoluene. So toluene on chlorination in presence of FeCl3, I am going to get ortho and para chlorotoluenes, two steps. So it is my option number D. So for 21, the answer is what? Question number D. 22. Let's go for 22. 22. What they said? Chlorination of, again same thing. Chlorination of toluene, but the condition is different. Chlorination of toluene. I'm taking CS3. Okay, chlorination of toluene. Then chlorination of toluene in presence of light. Okay, UV light or sunlight, you can say. UV light. Correct? UV light. Then followed by hydrolysis. Followed by what? Hydrolysis. Followed by hydrolysis. Followed by hydrolysis gives what? You are asking. So first, it will undergo chlorination in presence of sunlight. In presence of sunlight, if it is undergoing chlorination, obviously those 2, 3 hydrogens are going to be replaced by chlorine atoms. So I'm going to get CCl. If there was FeCl3 like earlier, I would have get ortho and para. But there is sunlight. In presence of sunlight, side chain halogenation takes place. So that is nothing but this one. So on hydrolysis, this one step, on hydrolysis, those 3 chlorines are going to be replaced by OH groups. OH taken place. Okay. So this guy is highly unstable. Why? Because on same carbon, 3 OH groups cannot be present. That is unstable. So as to attain stability, they will undergo dehydration readily. You remove H2O from this one. You remove H2O from that one. See, OH taken thrice, H2O you remove. You have, there are 3 oxygen, you have removed only 1, so I am left with 2 oxygen. There are 3 hydrogen, I have removed 2, so there is left with only 2. So toluene on chlorination in presence of sunlight will give you this compound. They said further it will undergo hydrolysis. On hydrolysis, this is unstable. It will undergo dehydration and gives what? Benzoic acid. Correct? So this is the reaction that they are talking about. So here for 22, I think, right? For 22, it is my option number D. So let's talk about 23 now. So let's go for 23. This is 22nd. Okay, 23. 23. In the following compounds, the order of acidic strength, all are phenol. Phenols are more acidic in nature. That you remember. Phenol, all are phenol. Correct? Compounds, aromatic compounds. Phenols are acidic in nature. Their acidic nature can be increased by attaching an electron withdrawing group. Please do remember. If electron donating group is attached, its acidic nature will decrease. So this will be more reactive or more acidic compared with an phenol which is attached to an electron donating group. This will be less acidic in comparison with a compound or a phenol which is attached with an electron withdrawing group. Or else you can say negative inductive effect. Negative inductive effect will increase acidic nature. Here I am having positive inductive effect. Positive inductive effect will decrease acidic nature. So based on this concept, if you are going to arrange these things, electron withdrawing groups, there are nitro in third and fourth. In third and fourth compound, there are nitro groups. So those are more acidic compared to 1 and 2. Then among and third and fourth, in 1 it is present at ortho position. In third it is present at what? Ortho position. In fourth it is present at para position. Correct now? It is OH. NO2 is present at ortho. NO2 is present at para. Where the effect will be more? Effect will be more at para. So that is why this compound, that is nothing but my fourth compound, is more acidic in nature compared to one third. I'm talking about the question. Correct? So fourth order is what? Fourth is more acidic. Fourth is more acidic than third one. Then among 1 and 2. In one, first one is phenol, second one is cresol, para-cresol. Among phenol and cresol, who is more acidic? Obviously, phenol is more acidic because cresol, in that cresol, I am having what? Electron donating group. Electron donating group will decrease acidic nature. So obviously, after third, I am supposed to get one. Phenol is more acidic, and then comes cresol. This is the correct order for question number 23. So that is why option number 4D. In fact, for 23, it is D. D is the correct answer. Okay. So I'll rub off this. It's acidic nature. The concept to be applied is what? Anti effect and resonance effect. Okay. Electron withdrawing group will increase acidic nature. Please do remember. 24. 24. Which of the following species is most stable? They said all are carbocations. Aromatic compound carbocations are present. All are benzyl carbocations. In first one there is NO2 group, nitro group. In second one there are no any substituent group. In third one there is chlorine. In fourth one there is OCS. That means electron donating group. CH2 plus electron density less. So if I am attaching an electron donating group, that increases stability. So that is why in case of D, if you are going through, there is CH2 plus, and to this one they have attached an OCS ring. This will electron donor. This is electron donor. It will increase electron density and neutralizes this positive charge. It will try to neutralize, in fact, not completely, partially. So that is why this guy is going to become more stable. So that is why for option number D. For 24, it is option number D. 23 was also option D, and 24 is also option D. Clear? So let's go for the next question. That is nothing but my 25th. 25th. Benzene reacts with CH3Cl in presence of anhydrous ClCl3 to form what? Obviously, it is Friedel-Crafts alkylation, toluene B. So 25 is what? B. So let's go for 26. 26 in Friedel-Crafts alkylation again. Same AlCl3 should be anhydrous. It should be anhydrous. They have mentioned. Right? You can go through that reaction. Why? Because it's a Lewis acid. Its Lewis acidity of AlCl3 will be lost if it is hydrated. If it is hydrated, if suppose there are moisture, if suppose there is a moisture, its Lewis acidic nature will be decreased. That is why for 26, it is my option number A. Clear? So let's go for 27. 27. Electrophile NO2 plus attacks the following most readily. The question is electrophile NO2 plus attacks the following most readily, or else you can say which among the following four options is more reactive towards NO2 plus or more likely to undergo nitration rapidly. Option A is benzoic acid. Option B is anilinium ion. See, option A is benzoic acid, which is an electron withdrawing one. It won't support electrophilic substitution reaction, so it cannot be the answer. Let's go for B. B is anilinium ion. They said anilinium ion is nothing but my NH3 plus. NH3 plus is anilinium. Anilinium means NH2. NH3 plus means anilinium ion. Anilinium ion also won't support electrophilic substitution reaction as it is electron withdrawing. It is also electron withdrawing. So let's go for C. C is benzene. Okay, it undergoes electrophilic substitution reaction, but they are asking readily. Let's talk about D2. D is what? Phenol, they said. In phenol, I am having positive resonance. It's an electron donor. So compared to this one, this phenol will readily undergo what? Nitration. It reacts faster with what? NO2 plus compared to all this. So that is why for 27, it is my question number. I mean option number 1, D. Correct answer for 27 is D. Okay, so let's go for 28. 28. When nitrating mixture is used for nitration of benzene, which molecule is acting as a base? Which is acting as a base in nitration? In nitration, I will take concentrated HNO3. I'll even take concentrated H2SO4. They are asking which is acting as a base. Yes, during nitration, please do remember HNO3 acts as base. So it is my option C. For 28 question, please do remember during a nitration we need concentrated H2SO4, concentrated HNO3 nitrating mixture. In that HNO3 acts as base. Please do remember. So that's why it is my option number C, 28. So let's go for 29. What they are asking in 29? In 29, the electrophile involved in the sulfonation of benzene. Benzene will generally undergo electrophilic substitution reaction. That is nothing but an example, sulfonation. In sulfonation, what they are asking, electrophile involved in the sulfonation. Which acts as electrophile during sulfonation? SO3 is dissolved in H2SO4. Earlier there was a question. So SO3 acts as an electrophile during sulfonation. So that is why 29, it is my option number B. Option number B is the correct answer for 29. During sulfonation, SO3 acts as an electrophile. Clear? So let's go for next question. 30. 30. What is 30th? Which statement is not correct for an aromatic species? Which component is not correct? Please do go through the aromaticity. They might have discussed in the class. Please once again go through all those things because this concept is very, very important as far as your NEET exams are concerned. They may ask more questions on this. Even tomorrow you can expect more questions and finding out which is aromatic, which is non-aromatic. It's like that. So the condition, which statement is not correct, they said. Let's go through the option A. It will have 4n plus 2 pi electron. Correct? They are asking which is not. Option B, it is planar. Yes, compound has to be planar. That is another condition to be what? Aromatic. First one, it should have 4n plus 2 pi electron. Second one, it will be planar. The structure should be what? Planar. Okay. Option 3, it will have 4n pi electrons. No, it should have 4n plus 2 pi electrons. But they said 4n. So it is wrong statement. That's what. Which statement is not correct? They said. So option number C, it will have 4n pi electron. It is wrong statement. Correct. So that is where for 30 years. The correct answer is what? Option C. Let's go for 31, 31st. Chlorobenzene on treatment with acetyl chloride in anhydrous LCl3. Nothing but aircraft. Chlorobenzene undergo acetyl chloride treatment with acetyl chloride. Acetyl chloride in the sense CH3COCl in presence of anhydrous AlCl3. Obviously, you are going to get two products. Electrophile will go and attack ortho and para. Okay? So that is why option number C it is. I am going to get orthoacetophenol and I am going to get parachloroacetophenol. CO is the orthochloroacetophenol, parachloroacetophenol. So 31 it is option number C. Correct? Let's go for the next question. 32. So my next question is what? 32. Nucleophilic aromatic substitution reaction is difficult. Why it is difficult? We generally know that aromatic hydrocarbons will undergo electrophilic substitution reaction. But nucleophilic substitution reaction is difficult. Why they are asking? Option A, it takes more time. That's not the specific reason. Let's go for the option B. Pi electron cloud of benzene ring repels in incoming nucleophile. Yes, aromatic hydrocarbons are electron rich. And if suppose you are adding a nucleophile, that is also electron rich. So when nucleophile comes closer to the aromatic compound, there might be a repulsion between what? Those electron clubs. Pi electrons of aromatic and electrons of what? Nucleophile. So that is why it is difficult. So 32, it is my option number B for 32. Okay, so let's go for 33. 33. Benzene reacts with Cl2 in presence of sunlight to give final product. We have already discussed from the beginning. We are discussing about this one. Benzene reacts with chlorine in presence of diffuse sunlight so as to give you BHC or gamexene or C6H6Cl6. I have written that reaction earlier. Correct? So that is why 33 is nothing but my option number 8 for 33. Let's go for 34. 34. Benzene reacts with acetyl chloride CH3COCl in presence of AlCl3 to give. Again, the question is based on what? Friedel-Crafts alkylation. And obviously, the option is what? D. Acetophenone. Which is acetophenone among these? Option D is what? Acetophenone. Correct? So that is the correct answer. Correct now? So let's go for 35th. What is 35th? The ratio of sigma and pi bonds in benzene. Ratio of sigma and pi bonds. How many sigma bonds are there? There are 12 sigma bonds in benzene. So there will be hydrogens over here. Correct? No? These all are hydrogens. So there are 12 sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12. And there are 3 pi bonds. 3 ones are 3 fours are. So 4. Ratio is what? 4. So 35 option number B. 35, it is option number B. Okay, so let's go for 36 then. 36 now. 36 question. Let's go for 36. What they are asking? Gamexene, that is nothing but C6H6Cl6. Gamexene is obtained from benzene when it reacts with obviously with sunlight. When it is diffuse Cl2 in sunlight. And in absence of catalyst, that is nothing but my B. So for 36, we have already discussed so many questions based on this one. Let's go for 37th. 37th. Which is most readily nitrated? Again, the question is same. Nitrated means nitro group is to be attacked. Where it, for whom it is easily going to attack, they are asking. So there should be an electron donating group attached to the benzene. So there is benzene, there is phenol, there is aniline, and there is nitrobenzene. So the strong donor is OH, phenol group, OH hydroxyl group present on benzene. So that is why option B is the correct answer for 37. Please do remember electron donating groups. If suppose electron donating groups are attached on benzene, they react faster with than what? Electrophile. They act as ring activators. They donate electrons and activates the ring towards electrophilic substitution reaction. So in that, phenol is more reactive. That is why option number B is correct. Okay. So let's go for 38. 38. See, ortho and para directing groups are mostly, I said you, they are activators. They are ring activators. Ortho and para directing means ortho and para electron rich. They are allowing electrophile to come and attack. So they are activating. So ring activators or ortho and para directing groups are called as what? Activating groups. So 38 is option number A. Correct now? So for 38, I'm having option number A. Similarly, let's go for the next one, 39th. I will write over here. 39th. Which among the following is the strongest ortho and para directing? They are asking. Same. OH, Cl, C6H5, Br. Who is the strongest activating groups? Obviously, hydroxyl OH. So 39 is again what? Option number A. Okay. Let's go for 40th. I'll finish it faster as we don't have time. Select the true statement about benzene, they said. Option A, because of unsaturation, benzene easily undergoes addition reaction. No. Option B, there are two types of carbon-carbon bonds in benzene molecule. No. There are only one type of carbon-carbon. Those are partial double bonds. Correct? There will be a resonance. It is not. Then there is a cyclic delocalization of pi electrons in benzene. Yes, that is a true statement regarding what benzene. There is a cyclic delocalization of what? Pi electrons in benzene, and that is why I'll get only one type of carbon-carbon bonds in the benzene molecule. So option C is correct. For 40th, it is option C. Correct. So let's go for 41. Aromatic compounds burn with sooty flame because, yes, we know that. So as to identify, aromatic compounds are to be burnt. So they'll burn with sooty flame. Why they will burn with sooty flame? Obviously, they will be having more number of carbon in it. That is why aromatic compounds burns with what? Sooty flame. So which option is correct? They have relatively high percentage of carbon. So that is nothing but my option C. 41 is C. So let's go through the 42, 43, 44, 45. We are left with those many. 3 fused benzene rings are found in, obviously, an example for aromatic. That is nothing but my anthracene. 1 benzene, 2 naphthalene, 3 anthracene. So anthracene is having 3 fused benzene rings. Anthracene, correct? I've been doing the structure. So this is my anthracene. Correct now? This is anthracene. There are 3 fused rings. So anthracene 42 is option B. So let's go for 43. 43. Benzene is undergoing nitration. What is X? Benzene is undergoing nitration means I'm going to get what? Nitrobenzene. Correct? No? This is my X, nitrobenzene. Then X on chlorination in presence of FeCl3. This on chlorination in presence of FeCl3 is going to give you meta-directing group. NO2 is meta-directing. So chlorine has to go and attack what? Meta position. So it is meta-chloro-nitrobenzene. Or you can say 3-nitrochlorobenzene. Right? So I'll write this structure over here if it is not visible. Chlorination in presence of FeCl3 will give you what? NO2Cl. NO2Cl. Or 3-nitrochlorobenzene. So option number B. 43, it is option number B. So let's go for 44. 44. Benzene molecule is structure of benzene. Obviously, it is a planar molecule, so it is option B. That's why it is aromatic. That is the condition I said. To be aromatic, the compound, the structure should be planar. Okay. So 44. So let's go for the last one. That is nothing but 45th. What they said? Benzene can be obtained by heating either benzoic acid with X or phenol with Y. Very interesting. So let's talk about the last one. Benzene can be obtained. Benzene can be obtained. Benzene can be obtained. I'll write in the big size. This benzene can be obtained either by heating benzoic acid with X, COH, benzoic acid with X will give you benzene, or phenol with Y will give you benzene. This is the question. Or phenol with what? Y will give you benzene. Phenol with Y will give you benzene. Benzoic acid with X will give you benzene. So what are X and Y? There is benzoic acid or sodium salt of benzoic acid. You can say X should be my decarboxylating agent. That is nothing but soda lime. So X should be soda lime. Then what about Y? We have discussed phenol benzene plus zinc oxide. That is nothing but my zinc dust. Correct? Zinc, and here it is soda lime. X is soda lime, Y is zinc. So soda lime and zinc dust, option number B. So 48th is my option number B. Okay. So here we have completed all these 45 questions of discussion paper. Thank you.